and a very warm welcome to this special webinar by ET Energy World on the topic Engineering, BESS and Hydrogen for Resilient Next Generation Energy Systems. We are delighted to have you all join us for what promises to be a highly insightful session. As the global energy transition accelerates, engineering innovations in battery storage systems and hydrogen are becoming essential to ensure grid resilience, flexibility, and long term sustainability. Today, we bring together leading minds who are not only shaping this conversation but also building the technical backbone for cleaner and smarter energy future. This session will explore the policy side of things along with technical challenges and integration of energy. We have with us two distinguished experts from Siemens who will be sharing their experience and perspectives. We'll be beginning with presentations by each of our experts, followed by a Q&A session. In between the presentations, we will also be coming up with a couple of survey questions to make this session interactive. Please feel free to share your questions in the chat box as we go along. First, we have with us Mr. Shivdeep Gagat. He is the industry lead for energy, Siemens Sim Center. He specializes in modeling and simulation technologies for R&D, engineering and operational excellence. Based in Berlin, Shivdeep brings over 15 years of experience working with leading EPCs and asset operators across Europe. We also have with us Mr. Anil Ogale. He is the portfolio leader at Siemens Digital Industries Software. Mr. Ogale is the Sim Center portfolio lead for Marine, ENU, and Federal Startup Space. He brings 2 decades of expertise in the simulation domain with deep cross-industry insight into technology, strategy, and application. A very warm welcome to you, Mr. Gagat and Mr. Ogale.
Thanks, well, thanks, Arushi.
I would like to give the platform to you. So over to you, Mr. Gagat and Mr. Ogale.
Thank you for that introduction. Allow me to share my screen. Hello, good afternoon. Welcome everyone who's joining. Very excited to share today's webinar and our experience with you. And by all means also learn from you and the things that you are active in. So really thanks a lot for taking the time to hear us out. So getting right into it, for today, the agenda actually goes as follows. We'll introduce ourselves and the company. We'll look into some policies, specifically on the India side, what's happening and how that impacts the overall sector. We'll report on some key challenges that we have seen in this ecosystem across globally, and then share our technologies and how these technologies can actually help address some of those challenges, share some success stories that we have had, and then end with a summary. So getting right into it, Siemens, as you all are aware of, is a pretty big company and it can get very confusing. So for today's session, just to be clear about which part of Siemens are we in. So overall, Siemens, you have different sectors like digital industries, infrastructure, mobility, and all the others. And we specifically, Anil and myself, are belonging to the software side of Siemens. So this is relatively a new side of Siemens. So a lot of acquisitions, including the most recent Altair acquisition, is part of this portfolio. And specifically today, we are representing Sim Center, which is a portfolio of high fidelity modeling of physics, multi-scales at different levels, and it integrates with a wider portfolio of product lifecycle management with IoT, so giving the customers a full, complete end-to-end solution for their engineering challenges. Looking at a bit on the global side, so there's definitely a lot of trends on energy transition. So we can't, forever stay on oil and gas that have powered our systems for a long time. And it's important to actually shift those away into more of a greener future. And Although that's an optimistic thought, the field itself is very challenging, of course, as we all know. And specifically in India, we've seen a lot of take up on the solar side, on wind side, and there are policies that Anil will talk about that are actually helping those along. However, and this is not just India, across the world, we do see certain limitations, certain problems and challenges with this 100% renewable uptake is that, you know, the sun doesn't always shine, the wind doesn't always blow. And these, for example, just a small example here is just this duck curve, which is quite famous. Basically, when your sun is shining, but you really don't have the demand for that energy. But when the demand is picking up, the sun is setting. So people are coming home in the evening, you have devices being turned on, and at that time, you don't have that direct connection to your energy from the green sources. So really, what the missing piece in this puzzle to actually make it financially viable and sufficient and powerful and secure and resilient to all our requirements is the topic of energy storage. Energy storage can be on different time scales from a few hours to days to months. And there are different technologies that fill those gaps. But today's session will specifically focus on long-term storage. And there are two solutions that really stand out. And one is with battery energy storage systems. So using those batteries to actually help, balance those loads out, to shave those peaks off, provide all sorts of buffering that is needed. And as a long-term storage in hydrogen, and specifically, we'll talk about green hydrogen today as an energy vector. Now, with that, I wanted to check basically in the audience what specifically some areas that you focus on. So maybe Arushi, I'll give to you for the survey.
Yes, right. Thank you, Shubdeep. So just to keep the interaction slightly more engaging, we have a couple of survey questions for you all. So first question is, what would be your main area of focus? So there are 4 options. We have 30 seconds to, you must have got a pop-up on your screens. Kindly click on the options that you think is the right one. And within 30 seconds, we will have recorded. So we have options. One option is green hydrogen production. Second is hydrogen storage, transport, or offtake. Third is BESS. So we have received our responses. So the highest percentage goes for BESS, battery energy storage systems, with 64%. Second is green hydrogen production with 24%. And lastly, hydrogen storage, transport, and offtake with 12%. Shivdeep, over to you.
Thank you, Rushi. That's an excellent survey. I think we are quite catered to the audience we have. Anil, I'll give it over to you to talk about the energy scenario in India.
Yeah, so when the Atmanirbhar Bharat initiative was launched, by our government, one of the key things behind the thought process was an energy independent India. And without that, the rest of the things actually don't align with our vision. And with the energy independent India vision, one of the things that was launched by the government of India is the National Green Hydrogen Mission, which was started in Jan of 23. And there is one overarching goal for that is to position India as a global hub for the production, export, and use of green hydrogen and its derivatives. Now, this is a very long-term project, nothing short, and a lot of things need to go into that. And to achieve this, some key objectives and outcomes were defined in stages. And the first stage, I think, is at 2030, where we try to achieve some of these things. And one is, try to move towards a global leadership. That is, make India a leading producer, user of green hydrogen. And how do we do it? That's an issue. That's things that we are going to tackle today. Now, that's obviously not going to happen overnight. We will achieve that in steps. And a stepping stone is, to develop green hydrogen production capacity to 5 million metric tons per annum and supported by 125 gigawatts of associated renewable energy capacity. So that's the step, or that's the target that we have for the next 3 to 4 years. A key outcome again of this is decarbonization. We significantly want to increase our green imprint across all the industries. We want to reduce dependence on imported fossil fuels. That's one of our major costs as a country. And I think we have a target of being carbon neutral and green by 2070. The next step towards moving towards this target is indigenous manufacturing. So today, if we look, most of our imports or products like electrolyzers are imported. So develop domestic capabilities in this technologies in this field, develop the infrastructure to support it. And the way to do it is invest. If we can generate employment in youth, if we can generate interest in youth, that is the way to go forward for this. And all of this then ultimately translates down to emission reduction, because if we can increase our green energy consumption, if we can increase our green energy production, that automatically helps us to achieve our decarbonization goals and also reduce the emission targets that we have set for ourselves. So with this, I'll hand over again to Shivdeep, who will walk us through the challenges. So setting this goals and outcomes is really the starting point, but how we do it and how we achieve that. So over to you, Shivdeep.
Right. So definitely there's a whole push on getting these technologies to be developed in-house in India. And especially when we talk about these technologies, the challenges are there, but depends on who you are and what you do, determines the kind of challenge you have. And of course, some are global challenges and so on. So really to get that push out and then to get these things ramped up. So I really separate the BESS and hydrogen sectors out here. And if you look at the market in terms of who's producing it, so the OEMs, the EPCs and the owner operators, they'll have some common challenges and some different challenges. So I've tried to summarize some of these here. So really, if you are looking to develop these battery packs as an OEM, so really the challenging bit is, how do you design the cell, what kind of cells, all these kind of requirements, new materials. So when you're looking at these cells, it's not just a technology that to buy, but really it opens up a whole R&D space where it's all currently in the making. So if really it's actually a race between different companies and countries to actually invest in these technologies and find the right ones that are actually very powerful. The thermal management of these packs. So, they have tests like ARC and HWS. I mean, those of you who are familiar with this domain, these kind of tests, and they're specifically targeted to avoiding these thermal runaway scenarios. So that's something we have seen that sometimes often you've got just a couple of cells leading to a chain reaction that destroys the entire thing, and that could lead down to defective manufacturing, which is really what is quite scary for the OEMs. Now, when you look at the EPC side, to integrate those cells specifically to a customer location, containerizing them, the whole thermal management of that container, the HVAC of that container, the subsystem integration. So how do they interact with other systems in place? Do you have other systems, and what do you have? And the whole suppliers and the bill of materials that is available. So maybe it makes, so just to point out a problem, let's say if you have a certain pack that is available at that time versus a better pack that will arrive in 3 months, does it make sense to actually add it up and get it running, or does it make more sense to wait? So a lot of these problems, they're all interlinked, and it's not and that leads me to the owner operator, because there is really no one size fits all. Depending on where the operator is and where that installation is going to be, who are going to be the buyers and consumers of that. Then owning the safety risks is, as long as, even if they get it delivered, safety risk is something that the owner eventually has to be liable for. All kinds of emissions, and that includes water and noise. So when you're looking at even the electrical side, you've got rotating equipment and other things, and also the transformers and so on. And finally, but not least, is the impact on the grid, and how does it fit in, and how can you actually use these technologies to enhance what you get into the grid from a green energy perspective. A similar set of challenges in the hydrogen side, but it's not very different. So it really comes down as an OEM to the design of these very new technologies of electrolyzers, the balance of plant around those, and sometimes you're also looking at liquefaction and really low temperature handling of certain materials. the integration of controls, and again, the suppliers. Similarly, with the EPC, you have to process that, you have to store that, and when you have storage, you've got problems like boil-offs, integrating that with the water management, and when these plants are done, even in a modularized way, there's a lot of complex piping and instrumentation that goes on. And finally, if you look at the owner operator, the end question comes down to an ROI, or for someone who's owning and operating this and taking that entire risk. Is the ROI in the end, and of course, the ROI, when does it break even? How well does it integrate with the requirements, and does it imply, how does it comply with safety and regulator compliance, and how much impact does it have on the reliability and uptime? So really, the challenges are pretty complex and quite specific, and also quite generic, depending on who you are and what the challenge is. And one of the ways to counter it, and one of the reasons why these challenges also arise, is that there are niche solutions, in the sense that the combination or the integration of different aspects is something that the industry hasn't really fully mastered yet. And this is not just India in general. We see a lot of divide between teams that would, let's say, look at supply a bill of materials. A different team in R&D would look at new R&D for new materials, let's say electrodes or electrolytes, membranes. There will be a different team designing a component, so be it a BESS system or an electrolyzer. A very different team, controlling and integrating those subsystems, and then a very different one for the system of systems. So really, if you look at this, you've got a lot of different players playing into the same kind of objective, quite disconnected, and individually we may have expertise, and we may have extreme amount of sophistication in our technology development, but what we have seen is, when it comes to interaction, collaboration, and integration of those technologies with the adjacent fields who are equally as good, that's where the next generation challenge lies. And this is really having an impact on these technologies, because it really impacts your development costs. And if those costs are high, the longer it takes to get to the ROI. Safety and efficiency are another problem. So you can have something safe, but which is not efficient. So over design is something that is very heavily done in these industries, simply because safety is a big concern. And the cost of properly designing things means that the whole loop needs to be repeated. So the longer it takes to iterate on a design, the less likely there are teams who are going to do it, and they're going to sign off with an additional safety margin. And this is one of the most underreported issues that we have seen across this industry, simply because there is no time. And finally, integration of different subsystems. So let's say if you're looking at, let's say if you're looking at the electrical sides of the systems, that's typically not enough in isolation. It links very nicely, or has to link very closely with the thermal side of things. It has to link very closely to the generation capacity and the entire physics that goes with it. And just to give an example, we will get into that later, as to how these integrations are needed. And so before we do that, I wanted to check the kind of audience we have and what their interests are. So Rushi, back to you for the survey.
So we have a survey question. What area of business are you involved with? Option A is OEM. Second option, EPC. Third option, consultancy or service provider. And the last option is owner operator. You must have a pop-up screen. You have 30 seconds. Please kindly select the answer that you think is the suitable one. You must have received the responses. Yes, the responses are in, and the highest percentage has gone to consulting/service provider with 33%. Second is EPC with 26%. Then we have owner operator with 25%. And lastly is OEM with 16%. Shivdeep, over to you.
Thank you, Arushi, for that survey. Very interesting results. I would say probably on almost an even split between different players. So Yeah, thank you all for participating in the survey. Thanks, that gives us a lot more insights, and I'll cater some of the things I say according to that. All right, so we've talked about the challenges. Now, how do we solve them? That can be in other. Just a second. Yeah, so this is sorry when we're talking about solutions, it's very important that we actually link that back to a requirement, and we integrate those requirements into the way we design things and in the way we assemble them or package them and deploy them. So really, if you're looking at the OEM side, so that development of a new component or a new product, looking at chemistry, all the way going to cell design, so integrating that chemistry into your cell design, and that's something I'll talk about our solutions later. But really, what I want to share here is really a concept of framework. And again, I want to reiterate that we don't have to do all of it. So when I'm making this pitch, I'm not asking anyone to do everything at the same time, but really have that as kind of like an end goal on the roadmap as to how do we get there, because every step we take will phase out levels of redundancy and time losses and make our processes more efficient. So really, what we're trying to say here is connect those requirements into your development process, integrate those development processes all the way from your materials to cells to how do you package those cells, looping that back into different multi-domain development, which means cross-domain, which is electrical, physics, mechanical, hydraulic. All these components need to come together. They need to comply with safety and regulator requirements, and when you're integrating them, they need to make sense in order to have an ROI. And when we're talking about ROI, that automatically addresses a secondary or actually a primary problem in these industries, which is the life cycle cost of ownership. Now, be that for hydrogen or for BESS, it's basically the amount of it's basically going to determine your profitability on this kind of an investment, and through that determine how successful these technologies are. And that is also not done in isolation. That links together with a PLM backbone. So when I'm talking PLM, so that links back to your suppliers, that links back to your data, that links to your transparency as to who is doing what at what project, what is available, what is not, what are the delivery times, and all of those factors sort of play into your design. There's a cross collaboration, so basically each team is aware of what the other is doing. There are ways to embed those technologies. We have technologies that can really extract these complex models into something that has a nice mask, and you can put that into any kind of hardware environment or software. And that really enables you to have a concurrent integration and an operating setup, including all the distributed energy resources back into a system with storage. Now, there's a whole webinar available on this. So if you have the QR link here, there's one of the colleagues. If you really want to are interested on the supplier management and the whole PLM and how it integrates, for especially for BESS systems, you can click on this link, and that'll take you to that webinar. So, so just to give an example of some of the solutions that I'm going to talk about here. So we'll discuss some use cases all the way from systems integration. So when you're talking to owner operators, and my guess is that some of the consultants will also work with the owner operators to give them things like techno-economic analysis of what makes sense for them. And then we'll go also into more on the component level. So what are the individual elements, what kind of engineering requirements they have, all the way down to chemistry and for both BESS and hydrogen. So let's say we start with the consulting and the owner operator segment that we have. A big chunk in the audience today. So I hope you will find this interesting, I hope. All right, so let's say as a consultant or an owner operator, you're required to get a techno-economic assessment of an investment that you want to make, right? So what aspects will be considered here? So there's clearly a geolocation aspect. So let's say you want to install certain solar cells like PVs. There'll be a geolocation factor to that. So where let's say if you're whether you're installing them somewhere in let's say Telangana versus somewhere in Himachal, that will be different. And so how much PV capacity is needed, what generation is predicted, what is the weather going to be like. So that's one aspect. Then design configuration, whether it makes sense to have certain type of cell, like a prism or a cylindrical or a battery A versus battery type B. What are the safety aspects of that? Number of cells in the pack, number of packs, how they are containerized. And these two are linked. So depending on what kind of generation you will have, will determine how much capacity you need to store it, and vice versa. So if you have a high solar capacity, you'll probably need more. And that gets even more complex because then you have control strategies. So there will be control strategies that may, optimize for power prices, or that may optimize for availability of certain equipment. So these control strategies will integrate your BMS and EMS systems, including your safety and stability and so on. And then you come down to the financial structuring, which means, what are your payback rates? So if you take a big loan out now, does it make sense to pay a low mortgage rate versus a large kind of rate at which you can probably get with better power pricing agreement right now or not? So there's a whole financial structuring of how these investments are done that needs to go all into this mix. So if you look at this problem, that it looks pretty complex, widely interactive, and very often what I've seen is the scenarios are cherry picked based on rules of thumbs. There's no holistic assessment of all possibilities, and that's what we can help you automate. So we have tools that allow you to have these portals, and pretty much all these optimization algorithms, so genetic, anthill, it'll automate all of that. It'll rate different iterations. So for example, one iteration could be with battery cell 1, geolocation 1, financial structuring 2, all these permutations and combinations, it'll hop on and do on its own. And in the end, what you're really looking at is an automated workflow to actually make these assessments quite easy and straightforward, and making sure also you're quantifying each and every step in that and each and every alternative in a price terms for your end investor. So just an example of this, we have, if you can have a look at the blog here, it's not showing the entire end-to-end concept because that's a bit more confidential, but it is still looking at a consumer load here. So let's say a food and beverage factory that wants to have more green energy so they can get better certification of their products, built with green energy. So they want to integrate a lot more solar energy into the system. Now, when you're integrating that, you're also needing some battery capacity to store that, to balance out the peaks and loads whenever they're needed. And when it's not there, you need to get that power back from the grid. So really, this assessment is looking at different financing structures based on the solar intensity curve, the battery performance, the loads of the system, and really looking at 4 or 5 different battery packs configuration and giving an assessment of what would be a good payback rate for an investor. And this kind of an assessment could be actually quite automated. We can have a nice mask that you can always fill up with a geolocation and all these factors. And in the backend, you can run these calculations and get back with an optimized. Extending that a little bit, so really also this is looking at electrolyzers, and this is where we bring together both BESS and electrolyzers, as well as residential consumption. So you're looking at really different renewable resources. So the ERs in your systems, you're looking at solar, you can add wind, and you're looking at also hydrogen generation. You can add storage, add compression, add the water loop, and as well as linking that back into the grid. And so there's a whole series of different energy sources that are modeled in the varying degree of complexity, alongside the electrical as well as the compression systems and the storage systems for hydrogen. And the reason to do that is simply because you need this kind of integration and predictability of different subsectors or subdomains to come together and really look at your energy, your consumption. So for example, here we have a different pie chart for December. You have less amount of sun. For June, it looks a lot more different. And some of that energy goes into the electrolyzer to power that. You can also use that in the fuel cell form. So if you have a solid oxide setup, it would go both ways. And what goes to the battery, what is discharged, when it's discharged, all those things are then taken into consideration. So going from the system side, so really, if you're looking at the OEM side of things, these battery packs can be really very problematic. There could be just 1 or 2 defective cells that could actually cause a lot of problems. And here I'm just showing some nice animation of some of the work that our teams did. If it plays, which it doesn't. Anyhow, so basically you've got these packs and you're looking at the cooling systems, and these cooling loops not only are on the outside, they're also going inside. They're taking into account the electrochemical behavior of each cell and in each module. And you're resolving that complex cooling system altogether in a detailed way. And through that, you can really speed up different iterations, different architectures, assess those, and get them to market quickly. And there are also models that are available that allow you to import a lot of test data that you have, set up the model according to those test data. So you have an apple-to-apple comparison and run all those scenarios pretty quickly, even on the system side. This video is like some reason. Right. Yeah, so there's lovely little spheres and different colors spheres. These are just molecules, and we have tools to actually go down to the quantum chemistry level and really allow you to design new molecules. And currently, the way that happens, it takes months to years to actually characterize, to develop a certain compound, to test it, to test its thermal properties, its mechanical properties, and in this case, even the electrochemical characterization, so the ion mobility and conductivity, all of those properties need to be physically tested. So that is a long cycle to get to that point. But if you are an OEM looking to accelerate that, this kind of a technology can really virtualize your materials test bench and give you all sorts of predictability based on only pure on computations to assess different kinds of materials, different kinds of polymers. Let's say if you're looking at membranes, all the way from their selectivity to conductivity to the mechanical strength, the thermal strength under high pressure situations, and so on. So, and it has some embedded AI, so it looks for the right molecules as you go along and develop that. So really, if you're looking at, if you're an OEM and looking at new novel materials for your characterization, this is one of the tools, and it links very nicely into the 3D setup we have. So with one of our flagship tools is Cesium Plus. You can integrate the rheological properties and the chemical properties of these materials and really run that test bench completely in a virtual way to scale up your production. Coming down now to the hydrogen side, so really electrolyzers is something that is going to govern this industry. So it's not a matter of what it is, it's who gets there first, rather. The technology is set to pick up. And here we are specifically looking at a kind of a gap electrolyzer, gap alkaline electrolysis. So, when you have these plates and you have reactions on them, they generate some hydrogen or oxygen. And the moment you generate that gas, there's a layer formed, and that impacts the conductivity, the efficiency. And for that, detailed analyses like this is needed. So here, for example, we're looking at the hydrogen gas generation. Certain part of the system you can see is blocked, and that was going to give you changes in current density and so on. So, and even on the system side, there are validations that we have done. So these are models based on which are relatively fast running, not the entire geometrical detail, but the performance, the behavior is characterized through equations. And we have some decently well-validated models implemented in these systems tools. And there are also capabilities to get these heavy computational models, run some a tool called ROM Builder, which is basically using a lot of AI methods like machine learning to abstract those computations from months and days sometimes to something that it can execute real time. And these kind of models can very well be integrated back into the systems tools. or actually these models, including the system models, can also be extracted from these authoring applications and embedded into even hardware that is running these edge computing on your edge devices. So really, from the Siemens side, we have the entire ecosystem. So even the edge devices, there's a different division, although that manufactures them. We work very closely with them to actually give them a lot more virtual sensing and all the things that are completely physics-based, extracted and embedded into those edge devices. So one example here I have is for integration. So those who are looking to transport and store hydrogen. And this is a use case where we had the hydrogen injected into the lines where you have two consumers, so two gas turbines here, and they are receiving normally natural gas, and we want to inject some hydrogen into it. And from what we know from the EON study here, which is published here, is that there's something called a Wobber index. I don't know if everyone's familiar with that. It's kind of a measure of what kind of fuel and what calorific value it has. So that shouldn't change beyond 1% per minute. And if that change is happening, there's huge instabilities in the existing, in the running turbines, and they go offline and they trip. So it's not something that you want to happen. And the Wobber indices for natural gas, let's say for methane-based and hydrogens, are quite different. And the buffering capacity of the pipes has a very strong influence on that. So when you're injecting at point A, it's not as, let's say, a step function, you'll not get the same response there because there's some buffering here and there. So you might get some pushback and push in. And that might lead to these jumps in Wobber indices. So what you see here are these two curves. So one is almost at 1%, the other one is crossing that. And the only difference is another additional 200 meters of that line pack that is going to cover that effect. And we have a very nice story with one of our customers in Germany we'll get to later on. And finally, as I said, we also have a different division of Siemens that looks into the hardware side of things. So these kind of controllers and PLCs that you can actually use your automation with, that's something all these models can integrate with. So if you're interested in this end-to-end integrations of the different the physics of different kind of DER generations. So in this case, we're looking at wind, we're looking at controlling that wind turbine, as well as powering an electrolyzer with that generation. The whole setup can actually be integrated into these PLCs, either virtually or also in the physical side with some connectivity and embedding of those models. Right, so at least I hope that gives a good enough view of different range of solutions we have, the integrations that are possible, which leads me to my next survey question. So Arushi, next, I'll pass on to you.
We have our next survey question. The question is, what would be the most valuable integration in your view? You must be having a pop-up screen. Kindly select the suitable answer. Option A, integrating HW and models as executable digital twins. Option B, integrating cross-disciplinary design. C, integrating DER generation prediction. D, high fidelity, reduced order models into customized systems. E, all these integrations need to be exploited in a phased manner. F, such integrations are not required. And G is others. You have 30 seconds. Please select the suitable answer.
So maybe I'll give a point of clarification. So integrating hardware and the models, and when I'm using the word executable digital twins, it means basically the models that are extracted out from authoring environments and used as executables. Yeah.
Thank you, Shabdi. We have the responses, and the option with the highest number of response with 52% is all these integrations need to be exploited in a phased manner to have a high impact on ROI. Excellent. After that, so that takes almost more than half of the split. After that, the second option is integrating hardware and models as executable digital twins. Third, we have with 14% integrating cross-disciplinary design with supplier BOM. Then we have integrating DER generation predictions, geofactors control with financials with 13%. And lastly, we have high fidelity reduced order models into customized systems with 5%.
And thank you, Arushi. That's a very positive outlook. I mean, I think we all sit in agreement that there is requirements for integrations, and that's really going to be something that drives the next phase in these technologies, because the way the old technologies were developed, they were not tools, and so the method was slow, let's say, adapted to those times. But the times we live in also gives us an advantage that we have the best, we are at a level of good computational levels, and we need to exploit that to the most. All right, good. Thank you everyone for participating in that survey. I'll move on to some success stories, and just a little caveat there. A lot of things that we have done are quite confidential and customer specific, so there are only a few that we can share with you. But if you are interested in talking to us, working with us together, we'll be more than happy to reach out to you on a one-on-one basis. So the first example I have here is for the integration. So, and it's from a company called Open Grid Europe, which is one of the natural gas providers for Germany, and they need to get their systems upgraded to tackle the energy transition. So things like hydrogen and even supercritical carbon dioxide are things that they would need to integrate into their system. So for that, all those retrofits, they use technologies that we have on the simulation side to assess feasibility and ensure safety of those systems. Another example I have here is from Northvolt. Although the company was just taken over by another company recently, but that's a company we partnered with some time ago, and specifically for the OEM, as a battery OEM, enabling them to design really state-of-the-art batteries, integrating all the way from chemistry to the stack design, to the cell design, and into the systems integration of all of that. So yeah, so the officially publicated studies are, let's say, commercial successes can be quite sensitive to share. So that's why we have to be a bit careful on what we share, but by all means, reach out to us if you're interested in more. With that, I'll pass to you, Anil, for the summary.
Thanks, Shivdeep. Thanks for covering the entire topic. Can we go to the next slide, please?
Mm-hmm.
So, as we talked throughout the presentation, the movement towards sustainable energy, movement towards green energy is not a problem that can be dealt in silos, or one does one thing, one does other thing. That approach is not going to help us achieve our ultimate goals, and we need a holistic approach for the product development. And what that holistic approach means is not working in silos, but bringing all of your groups together. So right from requirements definition to designing the various components or subsystems in that design, integrating them towards a system, then validating those systems. So just designing things is not going to work. You have to validate whether the system that you built is going to work for the desired geographical, commercial, and technical validations that it was done for. Then you have to integrate all of these systems. You have to integrate the control mechanisms that you built for that. So, just to take an example, if you're building a BESS system can be used, say, in Chennai, where it is very hot, or it can be used, say, in Himachal, where it is very cold, or Assam, where it's completely a different climate, it's rainy, humid. And the system that you design, you have to make sure that, and maybe you're designing it in Bangalore, Hyderabad, or Mumbai, doesn't matter, but you have to make sure that the system that you design individually meets the requirements. And also that system is going to fit in a mechanism where you will have generation by some source. It can be hydrogen, it can be solar, it can be wind. And the application might be different. It might be a mobile application, it might be an automotive application, a stationary application. So when you build this system, you have to make sure that it integrates into the upstream as well as the downstream applications. And this is where the holistic approach that you start right from the requirements, when you decide the requirement, this is what it's meant to do and how it is going to do at the end, and you bring all of this together. So what you see in this slide, right, these are not just blocks, but they are processes, or they are sub-processes in your entire design process which talk to each other. So if you have a requirement definition that you haven't considered when you're doing the system integration or the controls, this whole thing falls apart. So you have to make sure that all of these blocks talk to each other, talk continuously during the development process, not just in silos, one after another, but in a continuous manner, as Shivdeep earlier talked about, right? In a second or third slide. This is an integrated approach that has to go into developing these systems. And that is where the maximum success will come out of that. And this is where Siemens can help you. And this is also what we call as, building the digital twin of the component or digital twin of your product. And this is what we can help you do with the range of products that we have in our portfolio. Help you build this digital twin of your product, starting right from concept to operations. And that then cuts down your cost, your development cost, production cost, and also your operation cost. And this is how we propose to help our customers. So, and what we do is we believe that there are three main pillars of how we can support you in your digital journey, because digital journey is not something like you buy a software and then it's started and it's finished. It's a process. It's a methodology that you have to implement in your organization. It has to run in your DNA. And there are three main parts for this. One is the people, the technology, and process. And we at Siemens, our main bread and butter is the technology. We provide you with the technology, the tools, the expertise. But along with that, we also help you understand or grasp the knowledge, the expertise in both the tools and domains, and also help you set up the processes for this integration. Because without that, whatever we talk doesn't make sense. And this is where, as a Siemens, we bring all of these three together and then help you achieve maximum value out of your investments, out of your commitments. And that is how we believe that we should go forward to achieve what the ultimate goal is when we started at the beginning, to achieve our goals for 2030. This is the way we can do that.
All right. I think that's what we had for you today. And thank you very much for your attention. And by all means, reach out to us, to myself, to Anil, questions, and I'll hand it over to you, Harushi.
Thank you. So we do have a couple of questions, and I would try to take as many questions as possible because the questions are very interesting. So first off, we have a question. What is required to implement hydrogen storage and its applications to mobility and stationary usage? Anil or Shivdeep, who would like to take this question?
Yeah. So when we talk about hydrogen storage, right, one of the most important things is the design of the storage system and the safety aspects, because that is something that you have to be very critical of. Now, if it's a stationary storage, you have some leeways in doing that. But if it's a mobile storage that you're transporting, then the safety becomes really critical. And to design the storage system, then you need to be really careful of what your requirements are. So how much do you need to store, how much do you need to transport, and how do you want to maintain that safe level at all the time. So this is where product design and validation really becomes important. And you have to really, it's not like something like a rocket science. It's basically a straightforward methodology that you need to follow. You need to do so, make sure that whatever you're designing is sufficient enough to withstand the loads, the stresses that are going to be enforced on the system, whether it be because of the mobility of that or whether it be because of the station weather conditions or whatever it is. So this is a straightforward design and simulation problem that you need to take care of. Define your requirements, define what the intended use of the system is, and then you go about the process.
I'll maybe just add a couple of bits to that. So of course, when you're looking at storage, especially hydrogen, it's a very small molecule. So safety, as Anil pointed out, is the key concern. And one thing is the storage. So when you're looking at, also there's a lot of very high grade, extremely expensive catalysts and storage techniques that are used. So maybe an aspect to consider would also be novel chemistry. An aspect to consider would be also manufacturing of these specific kind of vessels where you store them. So it could be, let's say, if you're looking at marine, you want to ship that hydrogen on big spheres, that's one possibility, or you want to have it in cylinders, let's say for your car or for your plane. Those need to be also, there's a lot of research and development that needs to go into it as well. And then comes the uptake side, and there's different methods to monetize that hydrogen at different periods in its life cycle. If you're looking at a gas agency, it's something that you can incentivize an offtake, especially if you balance your power pricing and agreements in the right way. That could be made viable, and especially I don't know if in India it's going to happen. So these carbon credits is something that was implemented in Europe. So at some point we do expect that things will start getting taxed if they're emitting some carbon dioxide. So that might also be something that is kind of like a negative cost or negative profit if continuing as status quo. So that might also impact the financial side of it.
The next question is basically around the China challenge that is there, which Indians feel that is there in all the sectors. So the question is how we may overcome the challenges, especially for green hydrogen, as we are procuring most of the electrolyzers from China, and what is the way out for Indian businesses?
So we are importing most of them from China, yes, specifically electrolyzers and even batteries. Most of the cells are imported from China. And we need to start doing that in India. There is no other way out of that. There's no shortcut. Design and manufacturing has to start in India. And in fact, if you look at the National Green Energy Mission Foundation that I was talking about, one of the key points here or one of the keynotes here is that there is going to be sufficient or substantial interventions for encouraging electrolyzer design and manufacturing in India, along with financial benefits for such type of initiatives. So until we start, designing and manufacturing of these things, so electrolyzer cells, battery cells is another thing. Right now, we are almost importing everything from China, so we need to get that here. And manufacturing is okay, but to start actually getting something that's financially beneficial, we also need to start doing the design in India. And that is what the whole thing is about, this whole initiative that we are talking about up to 2030, 2040. That is why the time proposed or the timelines proposed are that getting your design right is not a straightforward thing or a first forward thing, but taking the steps towards that is what we want to start out of this. And this is what the idea of this webinar was also, how to move towards indigenizing thing, how to move towards an Atmanirbhar Bharat, where we start designing, where we start manufacturing our own tools, our own electrolyzers, our own battery cells, and decrease our dependence from China.
Absolutely. And if I can add something to that, I think from the statistics I've seen, compared to a lot of other countries, the R&D activities in India are heavily supported by the government. And in this case, I think it's aligning quite well that you have those policies and incentives, which should now target the corporate side. So that risk taking needs to develop, a bit more long-term thinking. And, it's not going to take that long because in terms of technologies, there are a lot of decently mature solutions. So really what we need is, some effort actually to understand these technologies, to apply them in a systematic way, and a bit of risk taking.
The next question is on BESS. So one of the audience members has asked, batteries don't have any resale value or market. Why is BESS still getting promoted?
I can say that actually that itself is also a big topic. And when you're looking at batteries, there's a whole segment of industry that is looking at the recyclability of those batteries. There's a lot of materials that can be extracted. There's revalorization of certain aspects. And even if it is, a long-term thing to actually recycle them, there will be some problems in each of these specific areas we go into. No one technology is a silver bullet. So, and then by no means anyone is saying that batteries will replace everything or hydrogen will replace everything. It's all going to be a mix of different technologies used to their best potential to first phase out a high carbon intensive coal sector in India, and then sort of slowly wean off the gas and or at least achieve a net zero in some way. There are clear disadvantages, but there are also some very clear benefits to using this technology. Yeah. So Anil, if you wanted to add to that something.
Yeah, no, I think what you said is perfectly right. It's not a complete solution, or it's not 100% replacement of anything, but it's a step in that direction. You need to look at it from that point. It's not a magic wand that you have and all problems are solved.
Yeah, and it also allows you to innovate also on the financial side, and even looking at the broader side of the ecosystem. So if you look at batteries, EVs are going to be a lot more efficient as well. So yes, batteries are hard to recycle, but again, is that 40% drop in efficiency worth it? With just burning coal out? Maybe not. And as we see in a lot of different sectors, as mobility is changing towards EVs, there could be new innovative solutions where you can actually use those batteries in the vehicles themselves as storage devices and sort of get compensated for or subsidized for an electric owning vehicle, whereas also keeping the grid stable. But yeah, it's a lot of steps until we get there, but there are chances and there are investments that are heading into those directions as well.
So we'll try to take as many questions as possible because we still have a couple of minutes with us. So next question is, what is the maximum amount of energy that can be stored in your BESS, and can it replace a DG set? This is directly a company specific question.
Yeah, I think that's something we'll have to take offline and understand the clear requirements. Yeah.
Another company specific question is whether Siemens has any plan for manufacturing electrolyzers or battery in India anytime soon.
That would be for a division of Siemens that does that. Sadly, it's not us. We can help you design them, to build them, to operate them, but we are not making any hardware. We're not making batteries, at least not our group. It's a different group that does that.
Okay. Does PEM technology has a future in green hydrogen mission?
Good question. It's one of those most used technologies. Whether it has a future or not, like, we cannot say that about any technology at the moment. The only thing we can say is that there's active research and active development going on in that field that are looking to make those electrolyzers even more efficient, replace some of the really expensive bits of that with novel materials, have high performing membranes. I mean, so there's things that are going on. So no technology is certain future and no technology is an uncertain future. So we're really playing in that racing game. So whoever gets to win with a technology that is sustainable and cost effective will actually win this race. So it's hard. I wouldn't answer the fact that it'll is there a future or not. There is a future, but it depends on how we make it today.
Next question is, what would be the cost of green hydrogen production? The $1 1 kg cost target that is there. So when will it be realized?
So I think the cost question is a very valid question. It's something that has a different, well, it's something that is all over the world, actually. The cost of green hydrogen is expensive. However, in this case, I think specifically, we are seeing a lot of activity, despite the cost inhibitions, to get the technology winning. So the cost will depend on what technology exists and what can be improved. And no one is saying that, okay, go scale it and just deploy. But we have to test it out. We have to learn. We have to iterate, improve, and sort of make this into a technology that works for everyone. And I think with incentives around manufacturing and developing that know-how to get those technologies up and running, that's something that is being also supported by a lot of governments in different places.
And one of the things here is we also need to understand that we are still in a nascent stage in this area. It's still a developing technology. It's not something like that's been in the market for the last 40, 50 years. We're still in the early stages. So yes, costs are high, but that is where the R&D and thought process is to get that down, and it will come down, because that's where the technology is going, right? It takes time.
Right. Next question is, what are the key considerations for designing a BESS that optimally complements a specific solar installation, taking into account the factor you mentioned earlier, such as geolocations, load profile, grid independence?
So there's geolocation and there's solar capacity. Now, solar capacity in itself is a variable. How much of it do you want to have? And that would determine how much storage do you need. Then the third aspect is the load, and how does that sort of fit into what is good enough to be stored and not. But that's something we can take up offline. If there's a clear problem that you have, we can maybe go into a deep dive and understand specifically how we want to solve it. And if you have the blog and the QR code for that, that specifically is looking at different battery packs. So let's say with 150 cells, 200, 300, with increasing capacity, you also increase your storage, but then how much is actually coming from the sun, so in a geolocation, and how much is actually needed by a customer who's back into that manufacturing. So have a look at the blog, and I think it will be at least to some extent clearer. And these aspects can be very, very broad, and we can also, we can go a lot more complex in that. So we can take it offline.
Next question is, how far can distributed generation go in India with solar PV, grid forming inverters, BESS, and demand side management programs?
It really depends, right, on what you want to do here, because technologically we are now at a stage where we have case studies where distributed generation is in place with tidal, solar, wind operating in tandem. How far we can go, that really depends on how far we want to invest our time, efforts, and energy into this particular problem. Right now, maybe we are not at a stage where we are commercially that successful to implement all of this together, but down the lines, maybe in about 5 years to 6 years, I think that's the way to go forward. That's what we are looking at. That's what we are aiming at. So with the conventional fuel sources getting down, everybody wanting to go green, some of them have pretty ambitious targets. In India, we also have a very ambitious target. So this is the way forward. There is no question about that. Within a couple of years, no, I didn't think so, but maybe 5 to 10 years, that's the way we are going to think.
Absolutely. I think that the question is not how far can we go, but to start. So how far we'll go, we'll only know once we start walking and running and falling, even, it's important. But yeah, we can't stay on a heavy amount of coal, and we can't stay on, gas environmentally harmful things. It's not good for our economy, and it's also not good for our people in general. So it's a step that we have to take anyway.
So we have just a couple of minutes left. I'll just try to take last 2 questions. So one question is, considering some recent failures of European companies in the hydrogen space, so in your expert opinion, is there a fundamental gap in financial viability, or are we in a natural maturity cycle of technology and adoption?
I think there are definitely gaps in the technologies, but I think it's failing is a part of it, because even before the investments were made, there are clear projections. Okay, the break even might take long, it might take shorter time, but what it does give you is that iteration, like the next one will not be that bad. So in the TRL terms, there may be certain technologies that are really quite nascent, and we're quite open and upfront about it. Especially when we talk about electrolyzers, there's a huge, they're really complex instruments. I mean, it's simple to say they just, produce hydrogen with water, but there's that complexity. If we can master that, that's where the challenge lies, really. And maybe the next iteration of these things will not be, will be probably more financially viable. With the upscaling of certain offtakes, let's say if you have more kind of demand come up on either the mobility side or for power generation, and we have ambitious projects from different other European companies that are not failing, that are still continuing, especially around mobility, around aviation. That will be one of the vectors that will go into the future. Depends on how we will use it, whether it makes sense for mobility or whether it makes sense for having green steel or fertilizers or a substitute for something or the other. But the technology to develop that, to produce that hydrogen on a green basis, is something that is unlikely to go away.
Lastly, I think supply chain is a burning question in every sector these days. So last question is based on that. So what do you think, what is your perspective on the need of robust supply chain development with quality, cost, and lead time in India?
You need that. There's no shortcuts to that. We need that, and without that, however technologically advanced we become, however good technology we have, if we don't have the supporting infrastructure, that's not going to work. And that is one of also the key mission objectives of this National Green Energy Mission. If you look, right, it's not just developing technologies. It is developing and supporting infrastructure, supporting ecosystem, and not just from a supply chain or a materials perspective, but also from a manpower perspective, from a resources perspective. And that is the mission and the whole. If you take, that's what the holistic approach is about. Now, for this, it's not just technology, it's defining the supply chain, the materials, the raw materials, the users, the skill sets that are required, the colleges or the universities to develop that skill set. All of this has to go hand in hand. And that's when we will reach the goal of energy independence that we have set for ourselves.
Shivdeep, would you like to add?
No, I think it's pretty much well covered. Although I would like to go to the previous question when it comes to hydrogen and some of the companies in Europe not doing so well. So Europe is not just the only benchmark. We also work with other countries, especially in Asia, with China, with Korea, with Japan, and there are a lot of very powerful technologies that we've also delivered. And for example, we can share a blog on the work we did with Kawasaki to actually develop a gas turbine that is fully functional on pure hydrogen. So there's a lot of investments in a lot of countries, and it's not going to stop because this is something relatively powerful for the future. And if this fuel can be mastered in terms of all its complexity, then we really have a very good play for that in the long term.
Thank you, Anil. Thank you, Shivdeep, for that compelling presentation. And thank you for the audience for those very interactive and interesting questions. I tried to take as many questions as possible. The questions were very intelligent. And thank you for joining us and sharing your questions. This session highlighted not just the promise of BESS and hydrogen, but the engineering depth and digital innovation required to make these systems robust, efficient, and future-ready. As the energy landscape evolves, such conversations are vital to align technology, operations, and long-term resilience. We hope today's insights will spark deeper thinking and collaboration within your organizations and networks. On behalf of ET Energy World, thank you once again, and we look forward to seeing you at our next session. Have a great day ahead.
Thank you all.
Thank you all. Thank you, Abhishek.